Okay, guys, here we go again. Matrices again, but we're going to start today. Actually, just before we start today, very special day today. Anyone who can, anyone who knows why it's a very special day will be getting a merit. And do remember, I'll be in the Zoom later in the lesson, so please check in after you've watched the video and then answer the questions with me to help you if you need to. Okay, we're going to start with this is just a revision exercise. So there's 3 questions there, all from A-level maths. What I don't want to happen is that we're focusing so much on matrices, complex numbers, and series, and all the other topics you've done that you forget about single maths. So can you please have a go at these 3 questions? And I'm going to give you about 10 minutes on that. Okay, so when you're ready, guys, off you go. Okay, that's about time. Let's have a look at the answers here. Okay, so the first one, we should be quite familiar with that. Well, there's the answers there. Again, I'll be in the Zoom if you want me to go over any of these. Hopefully they're fairly clear though, but it's important that you get them rectified if you need to. Okay. Right, okay, so moving on with matrices. We're looking at determinants today. So last lesson we multiplied matrices together, and actually we're going to do a bit of a recap on that, sorry. So we're going to do a little bit of a recap on multiplication. And what I'm going to do is I'm just going to give you a 2 by 2 matrix. And we're going to multiply it by something, and it's going to equal itself, okay? Now your task here is, can you find the matrix that when you multiply that matrix by it gives it itself, okay? And because we're trying to get, remember we want the 2 corresponds to the 2, so it's going to be 2 times something plus 3 times, it's going to be 2 times that value plus 3 times that value, and hopefully you'll see that in order for that to give me 2, this value's got to be 1 and that's got to be 0, because then 2 times 1 is 2 plus 3 times 0, that gives me 2. Similarly, to get 3 here, I need to do 3 times 1 plus so this top right one is 2 times 1 plus 3 times 0 gives me 2. 2 times 0 plus 3 times 1 will give me the 3 at the top there. And what you've just created there is what we looked at a little bit in the start there. That is what we call the identity matrix. Identity matrix. And it has to be in that form with the leading ones in that way in order for us to give the matrix the same as what we had before. And that works both ways. So if you started with the identity matrix, you would still get the right answer. Okay, hopefully some of you spotted that. Right, we are moving on. This is a bit of a strange thing to consider, determinants. I think, like with some of the other things we've looked at so far, trust me that there are lots of uses of the determinant. In itself, though, you might think, okay, what's the point of working out the determinant? And you'd be quite right to question me. But there are lots of uses, and we see one later in the chapter. So just trust me, but for now we need to know how to calculate them. So we're going to look at 2 by 2 matrices first. In fact, we only look at 2 by 2 and 3 by 3. So 2 by 2. Now if A equals, the matrix A equals A, B, C, D, then the determinant, of A, which is also known as det A, which is also known as this. I could do it in modulus brackets, or I could do A in modulus brackets. There's loads of different ways, or very occasionally it's a triangle. So the determinant of A is known as all those different things, but it's extremely easy to calculate. So I'm going to say det A, and it's always equal to the leading diagonal, so A times D minus BC. Okay? So that is what the determinant is. Don't worry about its use just yet. You just need to know that that's how we work it out. You'll see later on why that's the case and the uses behind it. So we also need to know that if det A equals 0, so if the determinant of a matrix equals 0, then it is a singular matrix, okay? You need to know that it's just known as a singular matrix. The reason for that is if you multiply a set of coordinates by a matrix with determinant 0, they will all become a singularity, which we will see in some future chapters. Okay, let's look at an example, e.g. Find the determinant of this matrix, find the determinant. Okay, so you can go straight in, and it's equal to 6 times 2 minus 5 times 1. So the answer there is 7. Okay, I can do this on my calculator as well, and it's very useful that you know how to do it. Let's just load this up. Okay, I go into matrix mode, favourite mode. Mat A, it's a 2 by 2, 6, 2. Okay, so the matrix is stored there. If I clear it now and go option, determinant 2, and then I go option again, mat A, so 3. The determinant of mat A, it gives me 7. So it works out the determinant for a 2 by 2 on your calculator. Right, EG2, so matrix A is 4, P plus 2, minus 1, 3 minus P. If A is singular, find the value of P, okay? So if it's singular, find the value of P. Now if it's singular, we look at our notes above, if it's singular, then det A must equal 0. So the determinant of A must equal 0 because it says it's a singular matrix. So the determinant of this matrix is 4, 3 minus P, subtract P plus 2 times negative 1. That's the determinant, and that must equal 0. So let's work this out. I get 12 minus 4P minus, let's just make that a plus 1. So it's going to be plus P plus 2, 0. So I end up with 14 minus 3P equaling 0. 3P equals 14. P is 14 over 3. Okay, hopefully I haven't made a silly mistake there. I apologise if I have. But that is how you work out determinants of a 2 by 2. And you'll see soon enough why that is useful. Now a 3 by 3 is less easy, I'll warn you, okay, and it's a bit more annoying, and you've got to understand how to do it. Not understand, you've got to understand the process behind it. If I label just a general 3 by 3 matrix, then the determinant, so I've put the straight line, so they're already the determinant. You take the first value at the top, A, and you multiply it by what we call its minor. And its minor is, I'll explain what the minor is. So the minor is when you, so we take A, we ignore the row and the column that it's in, and we take the matrix that's left. Okay, so that's this is known as the minor. That's known as the minor of element A. Okay. Now we don't just stop there. That's not the whole matrix. We have to go along the whole top row, and the second term is negative, which is annoyingly confusing. So it's going to be B. Now to get the minor of B, so the minor of B, we cross out that row because it's in that column, and we cross out the row it's in, and we're left with D, G, F, I. D, F, G, I. It's got to be in the right orientation. Okay, so that's B done. And then I do the same for C, but C is a plus. So it's C, and then the minor matrix of C is D, E, G, H. Okay, and then you would have, that's what you'd work out. This is often something that people forget. So this second term is negative. Okay. So, right, let's do an example. Let's do any examples. E.g., find the determinant of 1, 2, 4, 3, 2, 1, minus 1, 4, 3. Okay? So I simply just follow the process. So I start with the top left term, 1, and I multiply it by its minor determinant matrix, which is going to be 2, 1, 4, 3. I then don't forget the negative. I'm now on to the second element, 2, and the minor matrix of that is 3, 1, minus 1, 3. And then the third element is 4 there, and I times that by the minor matrix, 3, 2, 4. Okay. Now I don't just stop there. I actually have to work out the determinants of the 2 by 2. So it's 1, and then the determinant of this is 2 times 3 minus 4 times 1 minus 2, 3 times 3, which is 9, minus 1, and then the third one is 4, 12 minus 2, and if I tidy that up a little bit, right, 6, I get 2 minus, it's going to be 20 plus 14 times 4. Okay, and if I just tidy that up a little bit, do that, I've got minus 14 minus 18, I'm hoping is 38 is the determinant. You can obviously see there's lots of room for potential silly mistakes here. So, and I can do this on my calculator, luckily. If I go into the option again, edit matrix, mat A. Oh, in fact, I might define the matrix, mat A. Number of rows, 3. Number of columns, 3. 3 by 3 matrix, 1, 2, 4. You can see the power of the calculator now. But remember, the calculator will only do numeric matrices. Any with an unknown, you have to do longhand. Okay, so I've got that matrix in there. I can clear it. I go option, go down, determinant of at A, and fingers crossed. It's 38, good, it's always a relief. So I am right there, okay. Right, that is all the notes on determinants today. I'm not going to do any more today because I don't want to push too far ahead, but I'm going to set you lots of questions to practice. So question 2, question 3, this is all from exercise 6C. Okay, 2, 3, 4, 7, I want you to do by hand and check with the calculator. Okay, so hand but check with calculator 7. I want you to do 8, 9, 11 to 15, and then anyone who's really feeling like they want to push themselves, plus the challenge, okay, which is optional there. So there's quite a lot of questions to do there, guys. Please do join the Zoom session as soon as you've sort of watched this video and make notes, and then you can ask questions as well while you're working through the exercise. All right, but good stuff, and I'll see you again on Friday. Well done.